Geotrig, this is day 3 of lesson 1. So we got these things up here called vertical angles, or we're going to talk about vertical angles today. Looking at that diagram, what can you predict is the degree of angle y? So if we're looking at that, that's angle y right there. What are you guys thinking? What do you guys think angle y is? 65. Why would you assume that they're 65? Or why are you predicting that?
65 right across from y.
It's right across from y. Vertical angles, guys, those are called vertical angles. So 65 and y are called vertical angles. And yes, it is 65 degrees. It's because vertical angles are, we'll say, opposite each other. And they are the blank in their degree measure. Kind of blank, we don't fill in there. And are blank in their degree measures. We just said it earlier. Y is 65 because they are what?
Vertical angles.
Okay, they're vertical angles.
They're opposite.
They're opposite, which means they are the
Same.
So they are the same in their degree measures, or equal, congruent, if you want. So they're congruent in their degree measures. They're equal in their degree measures. That means, if I look at x and y, not x and y, hold on, let's back up. If I look at z and x, which are these two guys, what can we safely assume about z and x? Their degree measures are the same. So they are also the same. So we start to create likeness or same or congruent angles just by crossing two lines. Now, if that's the case, going back to what we did, I think it was yesterday and the day before, looking at x and y. That's this one and this one, x and y, right? So looking at x and y, what do you know about those two angles? Special word we learned yesterday. X and y.
Oh, complementary.
Not complementary. Supplementary because they form together. Together, x and y make a what?
180.
180 degrees or straight line.
Made it.
So these are supplementary. I probably should get a stylus. That would probably make it easier. So, wait a minute. If y is also 65, I'm going to erase that blue mark there. If y is 65, what does x have to be? What does x have to be if y is 65, there's 65 above?
Whatever gets you to 180.
Whatever gets me to 180. So to help me do that, I can take 180 minus 65, which is 115. That's x. And what can we safely assume about z? It's the same, 115. Now, could I have not done the same process with this? Saying that z and y are supplementary. They form a straight line or a straight angle. So therefore, they also add up to 180. Could I not do the same thing with z and 65 that's already told to me? Or 65 and x? They all work. Now, bonus question. What does x plus y plus z plus 65 equal? 360, because I went on a full circle. I went all the way around. Now we're on to triangles. So mixing it up, changing things over from angles to triangles, but triangles have angles, so that's fine. So number one, to say that two items are congruent, that just means what? I think we've already covered this.
Same.
The same. Easy enough. And we know that there are 3 angles and 3 sides to a triangle. We should also know, I think most of us would, that if I added up all the angles in a triangle, they'll add up to what?
180.
180 degrees. Correct. Here's the thing. It's not on here, but I'm going to add to it that if you know 2 angles in a triangle, you technically know all 3. If one of them's 20 and one of them is 30, then the last one has to be what? Not 150. 130. Because 20 plus 30 is 50. 180 minus 50 is 130. Okay? Now we're going to go into certain types of triangles. Okay? So these triangles here, we have a diagram. Now this diagram is something that I would use quite a bit for a lot of triangles. What we have here is a triangle that has A, B, and C. Big A, big B, big C. Big letters denote angles. The little letters denote the sides. Now notice where the little letters, it's a little hard to see on the screen there. But A, angle A, opens to side A. So there's a little a there. Side angle B, or angle B opens to side B. That's a little b. Big C opens to little c. Okay, so there's those pairs. A, B, B, C, C. Now, I'm not necessarily, we don't know anything about these particular sides and their lengths. I don't assume things, bless you. We don't assume things about these triangles. But if I saw a triangle that looked in that general shape, I would call that what kind of triangle? Based on its angles. And it's an acute triangle. It's an acute triangle because all of the angles are acute.
Yes.
And we know that about that triangle because all of the angles are less than 90. Next one is what kind of triangle with the A, B, and C?
Obtuse.
That is an obtuse triangle. So we know this is obtuse. We know this is obtuse triangle because it has what kind of angle? It has an obtuse angle. Question, can you have 2 obtuse angles in a triangle?
No.
Why? It'd be bigger than 360, not 360, but
180.
180. By definition of obtuse, it's bigger than 90, and 90 plus 90 in itself is already 180. That doesn't leave you room for another angle, so you can't close it back up. Okay, so how do we know? It has an obtuse angle. I'm not writing that, you guys can. And the last one, and I'm going to really be bad on spelling this one, Isosceles. Isosceles. That's not right. It's not isosceles, is it?
Better look it up on my phone.
I got it. Take my phone.
Now we got her fixed. Isosceles triangle. It says, mark what you know about this. Well, by definition, isosceles triangle has
All the same.
all the same side. No. Not 2 of the same sides. So if I put tick marks on those 2 sides, that's what I call an isosceles triangle. Actually, thinking about this, I should go back and we're going to talk about those other 2. So we're going to add some words to it. So, are we ready for me to turn back time?
Hold on.
So, seeing the isosceles triangle in there, I do want to go back here and I want to talk about this first one. It's an acute triangle, yes, but maybe that's why it says mark what you know about this triangle. If I went back and I said I put tick marks like this, because all of those sides really do look the same, and I know you can't make assumptions unless it's told to you, but if all three of those sides were the same, what other kind of triangle would that actually make? If everything is equal, it's a equilateral. Equilateral triangle. That's a really bad spelling there. It's an equilateral triangle. Equilateral triangle, all three sides are the same. And of course, it would be classified as an acute triangle as well. So that's why I kind of threw the first words in there. But by marking all three sides with tick marks that we did the other day, we'd say, hey, that's also an equilateral triangle. If anything, if I told you guys to make the perfect triangle, most of us would envision something like that, right? I would think so. The other one, it is an obtuse triangle. It goes by a different name if it looks like that. Because you could technically have an isosceles obtuse triangle. This one is a very special one. Look at A, B, and C. Could you look at that and say, oh yes, A and B are the same? Or A and C? Or B and C? All the sides are different. So, in this case, we'll draw a line here and kind of break away and say, all the sides are different. That's got a name. The name is scalene. A scalene triangle. A scalene triangle is when all of the sides are different. Guess what? If all of the sides are different, then all of the angles are different. Actually, did I even talk about that? I can't believe I didn't. If the sides are the same in a triangle, the angles opposite them are also the same. If I go to the isosceles triangle over here, that means if these two sides are the same, angle C is equal to angle A, because the opposite sides and opposite angles have to be the same.
Bless you.
Okay, so calculate the missing angle measure. I see that this could be a some problem, because you can't read it. That's 10. That's a 72 degrees. And that's also a 10. Calculate the missing angle measures. What's missing in this angle measures? What angles? B and C. So I want you to find both B and C. How can we do that?
Triangle has to equal 180.
Triangle has to equal 180.
You got 72 already figured out.
Okay, 72's there.
10 is on both sides.
Right, that's our key right there. What kind of triangle is this?
Isosceles.
It's an isosceles. I just talked about this. If you have an isosceles triangle, what do we know about opposite angles to those sides?
It goes the same way.
They have to be the same. So, what does that mean? It means that angle C, right here, opposite of this 10, has to equal angle B. Do we know what angle B or angle C is? No. What if I go through and I call that X? Is that okay for an unknown?
Yeah.
But if I call that angle X, What should I call angle B?
X.
Why X?
Same.
Because it's the same. Don't call it something different. They're the same. And then we go back to what Ty said earlier. It's all the angles have to add up to
180.
180, and you know 72 already. So what can we do?
Subtract 72 from 180,
Okay,
and then you divide that number by 2.
we can do that. That is part of the work. First, I want to set it up. 72 plus x plus x. Wouldn't that be the equation? All three angles added up should equal 180.
Yes.
Now we can start to solve. Maybe gather like terms. X plus x is,
2x.
so 180 equals 72 plus 2x.
Subtract 7.
Subtract 72. I'm going to run out of rooms there, but that gives me what? 108. 108 equals 2x.
And divide by 2.
Divide by 2.
54.
X equals 54 degrees. So that means A and B are both 54 degrees. And 54 plus 54 plus 72 equals 180.
Oh yeah. That's
Next problem. Calculate the missing angle measures, which happens to be all of the angle measures. Well, we know this one, right? So what does this one have to be? 90, because if it's right on one side, it has to be right on the other for a straight line. Good enough. It doesn't even label these things, right? Look at this. No label, no label, no label. Interesting. I could label them A, B, C if I wanted. Is anybody seeing anything familiar out of this?
2 and 1 are in the same spot.
2 and 1 in the same spot. What do you mean?
Like, they're on the same line in the same spot, so it's like already split up.
Already split up.
And then the 90 is the other degree angle.
Okay.
Perfect.
Perfect square? No.
Yeah, I don't know.
Yeah, I don't know where that came from.
Isosceles.
Isosceles? I don't know if I could say isosceles. I don't know. There's no sides that are the same.
Scalene.
So each one of these is a scalene triangle. You see that? 1, 2, square root of 3. Emily, what are you saying?
Is it equal?
Why?
Because the two, like one side.
Yeah, guys. These two add up to 2. Guess what? 2, 2, 2. Therefore, it's an equilateral triangle, which means all the sides are the same. That means all the angles are the...
Same.
So how many angles are there?
3.
So if I call just one of these x, how many x's do I have?
3 more.
3 x's should equal how much?
180 degrees.
So x is equal to 60. So that means you know all of those angles are 60. So this is 60. This is 60. This is 90. So 60, 90, what's left for the top?
60.
No. They have to add up to what? 180. So 180 minus 90 is minus 60. 30 degrees. And there you go. We're going to run out of time for the last problem there, so we're not going to do that one. Your homework is day 3, page 12, 9, 13, 15, 19, and 20. Have a great day.